Okay, so by now you would have watched the video on what a production possibility curve is. So now we want to learn how to draw the curve. So if you are a little bit new to graphing, we want to start from the basics. So let's pretend that we need to do an example that's in an economics textbook. That's where I found it. Good old economics textbooks. And we're going to just use shoes and watermelons because why not? Everyone loves watermelons. Everyone wearing shoes. Two good products. So first you want to go and you have two axes, axes. I don't know. You got 0 right here because that's the 0 value. Remember, if you go over here into other quadrants, usually you have 4 quadrants in a graph. These are negative, but yeah, and these are positive. I mean, it just depends on how you look at it, but this is where both values are positive, and so none of our values can be negative. I usually like to draw the line because they can go on for as far as you want. So in labeling it, you have the vertical axis, which is actually right here, which is your y. I don't know why I thought the other way. So let's make this one shoes. And then you have your horizontal x, watermelons. So usually factory good, farm good. Okay, so now we need to determine the points where all the resources of either making shoes or making watermelons is efficient. So this one's saying where you're using all resources to make shoes, no watermelons. So I'm gonna draw another one real quick. Abbreviate. So remember, this is 0. So if I'm producing 0 watermelons, I'm going to stay along this one. And we're going to have exact points in a minute, but let's just choose right here. We're producing all shoes, no watermelons. And then you want to look, if all resources were producing watermelons, you want to go, so you have go down 0 shoes, all watermelons. You have 2 points. Boom. So what are we going to do again? Okay, so we have, now this is where you need to kind of go make sure you have a little bit more attention. So if your 0's here, you are doing watermelons in millions. Okay, it makes it easier. Shoes in millions. So you want to make a scale. So you go 1, 2, 3, 4, 5, 6. Sure. 1, 2, 3, 4, 5, 6. Let's I could put a 7. So if you have to fit 21 million watermelons, millions, tons. Interesting. Well, you probably want to do like a scale of like, I don't know, you have 7 lines. If you do 2, you only get to 14. So maybe do like 5, 10, 15, 20. Do the same over here. 5, 10, 15, 20. And of course you can go 25, 30, 25, 30. So if you're doing 15 million pairs of shoes, and you're doing 21, so like 21, so it's just past the 20, and you make them meet. What point is worried about there? That's about exact I'm gonna get. This ain't graphing paper, so I'm gonna have to redraw that again, so that you're gonna get real good practice at it. So any other choices? We're gonna look at a chart to see what other possibilities are to get a better graph. So you can basically have a number of combinations of both goods. The big thing to think about when we talked about the extremes, where you have all of one thing and none of the other, it always kind of wonders, is that really the best choice? Stopping production of everything, because I mean, if you think watermelons or shoes, are you gonna have somebody that's like people that are gonna be like missing watermelons? I mean, you gotta feed people, right? You can't feed them shoes. So extremes are probably not a good idea because you want the best of both worlds. Remember thinking at the margin, how are you going to get the best combination? Okay, so we're looking here. And if I increase, think of my margin, it's a difference of 8 here. And there's a difference of 1 here. Then we go from 8 to 14, so that's going to be 6. 4 to 12, 2. And then if I increase by another 2 million tons here, oh, that's actually 6 million tons, but I can do math. And here you're going to decrease 3 million pairs of shoes. You increase 2, decrease 4, increase 1, decrease 4. That is a pretty good pickle, isn't it? Well, if you're going over here, you're decreasing 1, decreasing 2, 3, 4, 4. And over here, your margins of increase. What increase is the biggest increase with the smallest decrease over here? Is basically going to be looking at kind of where your combinations can go. Now you can go off the chart alone. Right here seems like a pretty good middle ground. You have only a couple of increasing going from 2 and then 6, but then you increase a 6 here and it increases 3 here. Well, that is not a good ratio. You don't increase more than what you increased before, but you have to decrease more than what you did before. So when it looks on a graph, so let's draw that graph again. You have 0, you have shoes in millions, you have watermelons in millions. Okay, so if I have 0 watermelons, 2 or 5, 10, 15, 20. I'm gonna go 5, 10, 15, 20, 25. Your scale can be anything as long as you make it fit in your space. Oh, I am so good at shoes. Okay, so I'm going to produce 15 million pairs of shoes and 0 watermelons. And then I produced 21 million watermelons and 0 shoes. So I got those 2 points. Extremes. Remember, extremes are bad. Well, if I go 25, 20 million watermelons, 5 million pairs of shoes, 18. Okay, this is a little harder. 18 to 9, you know what I'm at right here. You don't have to be that exact. We just need to get a shape, right? And then we're going 14 to 12 million pairs of shoes. And then we need 8 million tons of watermelons with 14 million pairs of shoes. And then you have 8. Oh, 0 and 15. Okay. And connect my lines. Oh my gosh, you drew a production possibility curve. So usually when we're looking at the most efficient allocation of resources, we want something around here because we start seeing the decreases going to be a little bit more equal between the two. And we're hoping that those efficient points are going to be the best points on our production. So that is basically how you draw a production possibility curves and why this information is so important in deciding the best combination for economic production between 2 choices. So thanks for watching. Hope this graph was a little bit easier to understand. Remember your axes and remember that this is much more simple than it looks. And we're going to be practicing these graphs a lot more. Hope you like production possibility curves. Have a great day, guys.